Today we will talk about planar Hamiltonian system. Planar Hamiltonian system. It's a very important topic in dynamical system. Okay. So first of all, what is the Hamilton's equation? So we do have Hamilton's equations in physics. So if we have x and y coordinates, so x dot is equal to partial h over partial y, and y dot is equal to minus partial h over partial x, where h is called the Hamiltonian. Okay, Hamiltonian. So we should know that we also have that Hamiltonian is actually constant. But how? But why? So we can see that. So if we take the derivative of h with respect to t, what we will get? So this is like very easy to see that. So we can see that h is a function of x and y, and then they both are function of t. So definitely then by chain rule, so this will be partial h over partial x dot, and then we will add plus partial h over partial y dot. Okay. So but now since we know that partial h over partial x and x dot is partial h over partial y, and plus partial h over partial y, but y dot is minus partial h over partial x, which is 0. So this means that clearly then h, x is a function of x, y is a function of t, so is equal to c. So that's why Hamiltonian is actually constant. But how this Hamiltonian is going to help us? So to see that, we will actually take an example to understand the whole theory. So we will assume an example. An example is actually that how this is going to help us. So example is that we are considering system x dot y, x dot is equal to y, and y dot is actually x plus x square. Okay, clearly we have 0 0 and minus 1 0 equilibrium points. Okay, and if we see the Jacobian or the matrix of the corresponding to the linear part is 0 1 1 plus 2x and 0. Okay, so a 0 0 is actually nothing but 0 1 1 0, and clearly we have lambda 1 2 is equal to plus minus 1, so 0 0 is settled. Okay, but if we see a 8 minus 1 0, we will see that 0 1 minus 1 0, and lambda 1 2 is equal to plus minus iota, so minus 1 0 is center. But if we see the real part of lambda 1 2, it is 0, so we cannot determine the stability of the system 8 minus 1 was 0. And if we have center, so center can be stable and unstable both. So now we will see how this Hamiltonian is gonna help us. So if we see the Hamiltonian, we know that since x dot is actually partial, x dot is equal to So we know that x dot is actually partial h over partial y, okay, which is what, which is actually by the definition y. X dot by definition it is y, right? So what is this? So this means that my h of xy is nothing but y squared divided by 2 plus h is a function of x. Okay, now if you take further the derivative of h with respect to x, this is h prime of x, and then what is partial h over partial x, which is actually minus y dot, which is minus x square. So this means that h of x is minus x square divided by 2 minus x cube divided by 3. Okay, this is my h of x and plus c. So clearly our Hamiltonian is something. So clearly, so my Hamiltonian is y square divided by 2 minus x square divided by 2 minus x cube divided by 3. So what if we see, okay, so also we can write down that since h is a constant, so we have different, for different constant we will have different Hamiltonian. So we can say that my this is h is actually y square divided by 2 plus u of x, where my u of x is nothing but this is minus x square divided by 2 minus x cube divided by 3. Now so if we see that equation, we will see that this will be plus minus 2h minus u. So now actually we are going to actually first draw u of x, and we can easily draw that by actually applying the first derivative test and see where the function actually crosses x-axis and what is maxima, what is minima. So clearly if we see that the graph of the u of x function, just u of x function, so definitely it crosses it minus 3 over 2 x-axis and then 0. So we will see, if you will be able to see that it is actually decreasing from minus infinity to minus 1, and then it starts increasing up to 0, and then again it starts decreasing. So this is function, this is actually minus x square divided by 2 minus x cube divided by 3. But now why this u of x is important? So that is gonna help us to sketch the face portrait. How? So we are gonna see that in a while. So we already saw that okay, if this is minus 3 over 2, this is minus 1. Okay, so this u of x is decreasing up to minus 1, and then it starts increasing, and then it starts again decreasing from 0 to infinity. Okay, so this is a but. Okay, now right below this graph, okay, right below this graph we are gonna have the face portrait. So but we will sketch the face portrait by the help of this function, which is u of x is actually minus x square divided by 2 minus x cube divided by 3. Okay, so now the method that we are going to talk about is called, actually this method is called projection method. So what we will do, because this is u of x, okay. So now suppose on this u of x we have different level curves. So suppose this is my first level curve h of 1. This is just assumption. Now since we saw that y is actually plus minus, sorry, we saw that y is actually y is equal to plus minus 2 of h minus 2. So definitely so y, for y it should be like h is greater or equal to u. Why? So because whenever h is greater or equal to u, we will have a real value, okay. That's where y will be defined. So now suppose this is my h1 curve on this graph, okay, since this is going down. So we can see that so if we can see that at this point the value of h and the point on u is actually same. So this means that this is the point where h is actually u, so y is 0. So in the corresponding graph, so this point will project to this point, okay. And now if we see that as u starts decreasing, or in other words, if as h is increasing, so as my u is decreasing, my h is increasing, so then my y is also increasing. So this means that my y will be increasing this way. But since it has two copies, so definitely the second copy will have something like this shape. So did you see how this the function u of x, the graph of u of x is gonna help us to draw the face portrait? That's what we see. Now suppose we have different h2, okay. So we have h2. So now again this is the point on the graph of u of x where the h2 value and u of x are same. So this means that my y is 0. So again this point is gonna be projected to this point. Now as my h is increasing, or another word as my, so as my the value of u of x is decreasing, my h is increasing, so my y is increasing as well. So this means that I will have this point, okay, this point. That's the because I have two copies for y, so definitely I will have two copies in my corresponding face portrait graph as well. Now now the main thing is actually, so suppose now, okay, now this is my another, okay, this is my this third point is actually intersecting the point on u of x graph. So suppose this is my h3. Now you can see that over here this is the point where h and u, okay, are similar. So this means that this is the point where my y is 0. So if my y is 0, this point is going to be projected to this point in the corresponding graph, okay. So now also if you look at this point, this is also gonna be projected to this point. But now as my u is decreasing, or in other words, as my h is increasing, my y is also increasing, so in this direction. So this, okay, in this direction, and it has the second copy for the negative direction, okay. Now the main thing is actually to see other thing, okay. So now this is my actually, now this is my h4. Suppose this is my h4, okay, this is my h4, very important point. Okay, so now we can see that this intersection point and this point, okay. So if this point is gonna be projected to this point, and similarly this point is gonna be projected to this point, since this is minus 3 over 2, so this is minus 3 over 2, and this is whatever we don't know. Now we actually need to see, now you can see this part is the part of u of x which is below the h4 curve. So definitely then y will be defined, because above, if I go above over here, if I look at the value of u that is above h4 or above h3, above h2, h1, that's where my y is undefined. So that's why I don't look at the values on the u of x graph which are greater than the h curves value. So we don't want those values. We are only interested in the values on the graph of u of x which are less than the h of 3y, because that's where my function y is defined. So now we can see that this point, this whole area, if we see between this point and this point, this whole area is also less than h3, so that's where my function is defined. So now see, so now now if we see, okay, so if we see, now if we see as my, okay, so now see, as my h is increasing, so it increases up to this point, my corresponding point, corresponding value will also be increasing, and it will increase up to this point. And then as my h is decreasing, my y value is also decreasing then. Okay, so this means that I will come to this point, but now it has two copies, so definitely it will have just projection or reflection, reflection. So you can see now also, because this is also the point on h3 where my function is 0, so this is the point. So now as my h is increasing, or in other way, my u is decreasing, my y value is increasing in this direction. And similarly it has second copy for the reflection. So now we can have so many other points. Okay, so suppose now this is my another new curve which is called h5. So this is my point, clearly this is gonna be projected to this point, and then this point definitely is gonna be projected to the origin. So now this whole area is actually below the h5 curve. So this means that as my h is increasing, my value will be increasing up to this point, and then it starts decreasing, so it starts decreasing, and definitely it will get to 0. Okay, and then it has second copy as well. So now suppose if this is my h6, suppose this is my h6 now. So now see over this point, okay, so this point is this thing. So as my, now again if I see the value that are below h6, so as my h is increasing, my value on y-axis is increasing, it will get to this point, and then because it at this point it starts decreasing, after this point it starts decreasing, so definitely I will then get to this point, because this is the point on y-axis, so definitely I will get to here, and then from there I will go there, and since it has two copies, so I will go there. So you can see the face portrait, we are almost done, but now we're gonna see the direction, because we don't know what is the direction or in which direction my solution is going. So that's very easy to see that. So my original equation was actually x dot is actually y. Now if my y is positive, my x dot is positive. Okay, This I know for sure. That what is the direction of my x dot? So if my y is positive, my x dot is positive, and if my y is okay, so if my y is negative, my x dot is decreasing this way. So you can see, so now you will see this direction, this direction, this direction, this direction, this direction, and also this direction and that direction. But over here, see, so a is my so now over here, so on this side, so a is my, again, a is my, when my y is positive, my x dot is increasing, so this way, okay, so this way, okay, you can see the graph. So now you can see that my solution is moving this way and it's following the pattern, and then it is going this way. So we can see that the solution is clearly moving away, and we can see the pattern. So that's, we saw that how Hamiltonian is gonna help us to actually see the solution pattern, where the solution is moving away or it's moving towards origin. So we saw that. That's the whole concept. I hope so you got the idea. First, to draw the phase portrait, first you need to draw the UFX, and then it's just projection. That's it for today. Thank you.